You might be thinking about changing out your natural gas water heater and doing it yourself without a plumber or handyman. If that's the case, and if you haven't done a water heater replacement before, there's a decent chance that using my notes will help. I'm a do-it-yourselfer with only a little experience in plumbing, and I recently replaced my natural gas water heater with the help of my 17 and 20-year-old sons. My main message is that yes, if you think that you might be able to do this job, you're very likely correct. You might have observed by doing other do-it-yourself home improvement projects that they can easily take much longer than we expect. In my experience, a big source of wasted time is spent going back and forth to the home improvement store. My hope is that by using my notes, the pattern of shopping and doing, followed by more shopping and more doing, and then another trip back to the store in a loop that goes on longer than you'd care to admit, is mostly avoided. Especially with a water heater project where you're probably out of hot water in your house from the moment you start draining the tank, time is precious and it pays to be prepared. My new water heater is a tank-style water heater fueled by natural gas. My old water heater was very similar. This video is most likely to be worthwhile to you if you've got a similar thing in mind, and if you want to be efficient with your time. It covers some tips for buying the water heater and the stuff to get it connected, and it goes through the installation process with a focus on the tools and materials you'll need to be ready for the big job. Taking an overall look at the process can help save time because it helps us think of what we'll need for future steps. If I go to my local home improvement store, for example, and start looking at water heaters without knowing a few key measurements of the space available for a water heater in my utility room, I may not get very far in my shopping. Only after getting to know the key measurements of your situation is it really worthwhile to go shopping in earnest. My recommendation is that you try online shopping for a water heater, even if you have a store near you that has water heaters in stock. I found that the selection was much better online when I was shopping. I made my purchase online and then I picked up the water heater from the store. Once the water heater is purchased, then the additional components such as the drain pan and the connectors for the water and gas are what need attention. Once you have those components purchased, the time is right to plan out the installation and acquire the tools and materials for the job. The big step of starting the installation comes after some relatively thorough planning, ideally. Again, hot water isn't available during the time you're actually working on the replacement, so in most cases, time is of the essence. When we do the measurement step of the process, the diameter of the water heater tank is a key measurement to have. I found that the new water heaters run wider than their same capacity predecessors due to a recent regulatory change that requires more and better insulation in the tank walls. When you measure the widest diameter your spot can handle, keep in mind that regulations require that a few inches of distance be kept from combustible materials. Since the venting is done from the top of the water heater, the ductwork might be the limiting factor on how high your next water heater will be. As a do-it-yourselfer, my interests were in doing as little to the existing ductwork as I could get away with. I did select a water heater that had a higher draft hood due to a powered damper. The vertical run immediately above the draft hood needed to be shortened in order to make room. I read in a few web articles that the first vertical run should be 12 inches long. Luckily, my modifications didn't shorten things past that distance. I don't know how hard and fast that vertical venting rule is, and I didn't research this rule heavily. You may benefit from knowing that there are apparently some rules about how close to combustible materials the top of the water heater can be. The vertical distance from the bottom of the water heater to the gas inlet is an important measurement for some installations. My understanding is that there are some locations in which flexible braided connectors aren't allowed, so the alignment of all the rigid black pipe is a factor in how involved or complicated the replacement job is. In my situation, the flexible gas connectors that are available at the home improvement store are allowed, so this measurement was not as important as it might be for others. While you have your tape measure out and in your hand, you might also want to estimate how long a cable run would need to be to get from the top of your water heater to an electrical outlet in a responsible way. There are several models available now that require electric power because of some efficiency features or some smart home features. The building inspector might not approve of an extension cord in use for that purpose. With those measurements collected, another important number to decide upon is the desired storage capacity of the tank. Your motivation for replacing the water heater might be to stop running out of hot water. In that case, you might want to go bigger, unless you think that there's just a whole lot of sediment taking up space in the one that you're replacing. The sizing of a storage water heater is a household size and lifestyle question. There are rules of thumb available. In my case, my blended family household ranges between 2 and 7 people, depending on the day. So I replaced a 50-gallon tank with another 50-gallon tank. Your old water heater likely has a sticker on it that provides the capacity of the tank. To sum up the key parameters for water heater shopping, I'd say that the 3 most universally needed are the maximum feasible diameter, the tallest feasible height, and the capacity. With those parameters collected, it's time to go shopping. For the sake of saving time and being aware of all your options, you might find buying online to be a good choice. In the United States, the national home improvement retailers Lowe's and Home Depot carry water heaters, as does a leading regional home improvement store, Menards. Your local Ace or Do It Best hardware stores are likely to have water heaters, and they have online retailing too. For online-only water heater purchases, you might try supplyhouse.com, amazon.com, and Zoro.com. Several online suppliers offer one-day delivery, so those with a need for getting the new heater in place quickly might have a viable option with them. Some local appliance stores might carry water heaters as well. My advice regarding filtering water heater search results is that capacity and vent type are 2 clearly useful filters. I'll have some comments about vent type in a moment. When I was shopping for my new water heater, I wanted height to be a useful filter, but unfortunately, there is no clear dividing criterion between a short tank and a tall tank. There is about 8 inches of overlap between the categorizations, and it just happened to be about the height of my existing tank. It seems that California and Utah have some regulations about NOx, or oxides of nitrogen, so filtering on those might be of interest based on your location. Warranty, price, and several other filters are obviously useful for your preferences. My understanding of warranty is that the only difference between 2 otherwise compatible water heaters of the same manufacturer but different warranty would be the quantity of anode material in them. The anode is what resists corrosion in the water heater, so the less anode material, the faster it will generally be to rust and eventually leak. My comment on vent type is that a large majority of water heaters are configured for atmospheric venting. If it appears that your water heater ductwork leads to the roof, then you've got an atmospheric venting configuration. If it appears that your ductwork runs to the outside through a wall, then you might need to investigate further. A.O. Smith has a nice page on the various venting configurations. Also, note that a powered damper system doesn't mean the same thing as a power vent configuration. I got confused about that. As you shop, you might keep in mind that your natural gas utility company might offer a rebate for those buying higher efficiency water heaters. In my case, the rebate was worth about 10% of the cost of the water heater and the connectors. So those are my thoughts about purchasing the new water heater. Taking stock of where we are in the process, we might find that finishing a well-considered purchase is an accomplishment in and of itself. Next is to select the components for connecting the water heater to the water and gas systems in the house. To take an overview of the major connection components, we can look at the contents of a water heater connection kit from the water heater manufacturer, Rheem. We might look first at the water line connectors. This kit contains compression fit connectors that involve just 2 wrenches or channel lock pliers to put on. I infer from the ubiquity of water heater connection kits that water heater nipples, the short threaded pipes that facilitate the water entering and leaving the tank, are pretty consistent in their diameter. They fit the 3/4 inch NPT or National Pipe Thread standard. It would have saved me some time to know or infer that a few weeks ago. The water connectors I would recommend would either be compression fit or push fit. Since experience and skill in soldering might put you into advanced territory beyond the scope of this video, the good news is that the compression fit and push fit options are accepted nationally. Since I'm guessing that you might be like me and have a little concern about making leak-proof water connections, let's talk a bit more about these 2 types of plumbing fittings. Let's start with push fit. Several companies make push fit fittings. SharkBite seems to be the dominant one in the home improvement stores near me. The other end of a SharkBite water heater connector is a female threaded fitting that screws onto the nipple of the water heater. This diagram is a cross-section of a coupling, not a water heater connector, but I like that it shows what's going on inside a SharkBite fitting. One thing I really like about push-fit connectors is that they have a stop, an internal obstacle, to keep you from using too much effort and ruining your connection. Once the existing water pipe is cut and deburred at the right position, making a push-fit connection is just a matter of using your hand to push the fitting onto the end of the pipe to a standard depth that the stop represents. The other two elements I find interesting about the internals of a SharkBite fitting is the rubber O-ring that provides the seal and the teeth that are probably the inspiration for the SharkBite name. The teeth allow the pipe in, but then prevent the pipe from leaving the fitting. It reminds me of the traffic spikes that are a bit intimidating to encounter when you enter a car rental or return at the airport. Compression fit water heater connectors are very similar to push fit connectors. On the end that connects to the water heater nipple, they are the same. And compression fit connectors don't require special tools either. Two adjustable wrenches or channel lock pliers can do the job of making the connection once the existing water pipe is cut at the right spot and deburred. The key idea of a compression fitting is that the compression nut, when tightened onto the threads of the fitting, is loaded with tension that has the result of pushing the compression sleeve against the pipe, creating a seal. One piece of advice about compression fittings that I picked up by watching YouTube videos was the idea that things start squeaking when you've tightened a compression fitting hard enough. It can damage the pipe and the seal to overdo the tightening on a compression fitting. In the slide deck that I created for this video, I have links to some other YouTube videos that explain the compression fittings and push-fit fittings and how they work in more detail. The video description has links to the presentation slide deck. I used SharkBite water heater connector for my project, and the main reason I used them was that they were what I found prominently displayed at my favorite home improvement store. I like to think that I'd be just as game for trying a compression fit connector next time. After connection type, the other concern for water heater connections is the length of the connectors. I bought my water heater connectors a la carte instead of relying on a kit, as I was interested in getting shorter ones and avoiding loops. My research did give me comfort that there's nothing wrong with looping for the flexible connectors for either water or gas connections, however, as long as there aren't any kinks in the line. To measure the lengths you need, predict the position on the existing plumbing where you expect to have the connector end, and measure directly from that point to a point in space where the end of the nipple of the water heater is likely to be. Then add a couple of inches. Since there are flexible connectors that can be gently bent and looped, err on the side of getting extra. Moving on to gas connections now, I'll say that I would suggest going with a flexible gas connector unless local code in your area requires the use of rigid pipe. Regarding length, I'll say that my experience with flexible braided gas connectors is that the minimum length available at my favorite home improvement store was 2 feet or 24 inches. I think it's very common to loop the gas connector. Making a loop and having a moderately longer connection than you might actually need really removes worries about the height of the gas inlet on the new heater versus the old. It took a little while for me to get comfortable with the sizing of the gas inlet to the water heater. It seems as though they are all a standard size, because that's the only way that these generic water heater connection kits could be so bold as to include a gas connector. But I had lots of doubt. The answer, it seems, is that 1/2 inch NPT, where NPT stands for National Pipe Thread or National Pipe Thread Taper, is the standard. The key concept that I struggled with is that plumbers use inside diameters when they speak of threaded pipe. When I looked into the water heater's gas inlet and measured it for size, it measured roughly 3/4 inches in diameter. I was expecting some website somewhere to tell me that gas water heaters use a standard inlet that had a diameter of something like 3/4 inches. Well, the resolution to my confusion about the sizing comes from a couple of realizations. For natural gas water heaters in residential settings, tubing of 1/2 inch inside diameter is adequate for the necessary flow rate of gas needed to run the heater. And the NPT standard is a very well-established standard in the United States. So the plumbing world considers the gas inlet size for a typical residential natural gas water heater to be 1/2 inch NPT. A concept important when planning the gas connection for a water heater replacement is that having a sediment trap in the configuration is mandatory. Before I was aware of that fact, I was tempted to think about getting a long gas connector and bypassing most, if not all, of the black pipe in my configuration. That's not good, however. The good news is that black pipe can be reused, so there's just a little bit of work in reconnecting those pieces after you've swapped the old water heater tank for the new one. Returning to the water heater connection kit, I should mention that many water heaters arrive with the nipples already included and installed, so you are likely to not really need the nipples in the kit. This kit has both yellow and white PTFE tape. PTFE tape is also known as Teflon tape. The yellow tape is for gas connections and the white is for water. As we finish talking about the essentials regarding water heater connectors, it might help to cover the key items of jargon that you might encounter as you do your shopping. We've already mentioned a few of them. NPT means National Pipe Thread Taper. It's essentially a standard pattern for pipe threads that includes a taper. The initializations FIP and MIP stand for female iron pipe and male iron pipe, respectively. And from a what fits what perspective, it's synonymous with NPT. PTFE tape is the proper brand-free way to say Teflon tape, polytetrafluoroethylene. The nipples of a water heater are the short threaded pipes that stick out of the top of the tank and connect to the water piping in the house. PEX is a polyethylene pipe material becoming popular for water lines in homes. And a TP valve or TPR valve is a temperature and pressure relief valve. While it's not a connector, a drain pan is something that still needs to be selected in a proper size. The drain pan wall should have a minimum of 2 inches from the water heater tank wall. I ordered my aluminum drain pan for pickup from the home improvement store, but it was pretty dented and deformed when I pulled it out of the box. I did my best to pound out the deformities with a rubber mallet. Once you have the connectors as well as the drain pan selected and purchased, you're ready to plan and prepare for the removal and the installation project. Preparation might include acquiring or arranging for tools and materials that you'll need. So let's walk through the process of removing the old water heater and installing the new one. And along the way, we can make mention of the tools and materials at each step. The work of removing and installing can be broken down into 5 big steps. Draining and disconnecting the old tank, moving the old tank out and moving the new one in, connecting the new water heater and filling it up, testing the connections, especially the gas connection, and firing up the water heater. We'll further break down each of those steps, and we'll make notes of the tools and materials needed. The first step is to connect a garden hose to the drain valve. Put the other end of the hose somewhere water is relatively welcome, such as a floor drain. For our list of tools and materials, a hose might be the first item. Shutting off the valve that isolates the water connecting to the water heater is the next step. If your situation doesn't have one of those, then shutting off the water supply at the main valve for the whole house is likely to be required. Depending on the valve you'll be turning, you might need a screwdriver or possibly even a special tool. In many cases, it will just require your hand, however. Another step that just requires your body is to go up or downstairs, or down a hallway, or whatever direction from the furthest hot water faucet is from the water heater you are replacing, and then open that hot water faucet. Doing this helps the drainage process by allowing air to more easily replace the water that's about to drain from the water heater tank. I'm not expecting this step to require any extra tools. Once the water is running out of the faucet, you're in a good position to open the drain valve of the water heater. You might need a screwdriver to open the drain valve, probably a flathead. You might check the other end of the hose to make sure water is now flowing through the house, but you probably will be able to hear the water draining. Next, the valve isolating the gas flow to the water heater should be turned to the off position. The handle is perpendicular to the pipe when the valve is turned off. It's possible that you might need a screwdriver for this valve, but in many cases there will be a handle. Once the gas is off to the water heater, the gas fittings can be disconnected. There's no particular order that needs to be followed for the disconnections. The tools needed here will be 2 adjustable wrenches or channel lock pliers. It's important to stabilize the joint by using 2 wrenches as you loosen things. I've seen recommendations of 10-inch adjustable wrenches, although certainly there is some flexibility in the size of these highly adjustable tools. The righty-tighty, lefty-loosey rule is in play here, and righty means clockwise from the perspective of the end of the threaded pipe. Sometimes it helps to turn in the tightening direction as you break an old seal, though, before going back in the loosening direction. So if you make a mistake with the lefty-loosey rule, it can actually work to your benefit. You might want an empty plastic ice cream pail or similar container to keep the gas connection parts, since they can be reused. That bin for parts might be useful in the next step, which is to disconnect the ductwork from the draft hood. You may want to keep the screws and reuse them when you reconnect the duct to the new draft hood. You'll need a screwdriver, probably one with a Phillips head, for the screws. Whether you need to cut anything away before you bring in the new water heater will of course depend on the height of the new versus the height of the old. Tin snips are likely to be handy if you need to make room. We did some measuring and calculating to figure out the new height of ducting that we would need for the new water heater, and we used blue painter's tape to do the marking. I don't think that's standard practice, but it worked. It was relieving to see how much play there is in ductwork, as well as in the other piping. It helped me to be comfortable with the plan to reuse the existing ductwork as much as possible. Water heaters take a while to drain, maybe 20 to 30 minutes or even longer, but the tank is likely to be fully drained by this step in the process. Now it's time to cut the water lines. We made our disconnecting cuts fairly low and close to the existing water heater. The actual tank part of our new water heater was very close to the same height as the old tank, so there wasn't much concern about making room for the new tank by cutting the pipes at a higher position. Copper pipe is easily cut with a pipe cutting tool. There are a number of styles, but I kept things simple and relatively cheap and just bought one that is specific to 3/4 inch outside diameter copper pipe. To use the kind I bought, you just snap the cutter into position around the tube and then rotate the cutter around the tube with your hand. It's a great design in that the design prevents someone like me from making a crooked or jagged cut. At this point, the old water heater is basically disconnected. The drain pipe for the temperature and pressure relief valve can be reused, so unscrew that pipe and put it aside for future reuse. Disconnecting the hose you've been using to drain the old water heater tank is a little step that might make it easier to move the tank out of the way. At this point, your old water tank is very close to being ready to move, if it's not already completely ready. Things to consider are earthquake straps if those apply to your situation, or an electrical cable if your old water heater required electricity. When you move the old heater away, you might be able to shuffle it along a floor by yourself without either a helper or a hand truck, also known as a dolly. But I would recommend either a helper or a dolly, or both, for these steps in the project where you're moving water heaters around. Water heaters are heavy and bulky. I recommend putting the water heater in a drain pan because I've seen that it's pretty easy to get water damage from a rusted out water heater, and anything that helps control the flow of water is probably worthwhile. And if you're planning to put the water heater into a drain pan, having help, whether from a human being or from a dolly, is safer by far. I had both of my young adult sons helping with the water heater placement, but I did some research about how people use dollies to do water heater installations without another person helping. It does seem possible. One tool I haven't mentioned yet for a water heater replacement is a box cutter for cutting apart the box that the new water heater arrives in. I have found that water heaters are fairly easy to pivot or wiggle into the spot and alignment that you want. For me, aligning the draft hood of the new water heater to the existing vent ductwork was the first priority, and then aligning the gas inlet with the existing gas fittings as much as possible was the second aligning priority. Once the new water heater is in place and aligned to your satisfaction, it's time to start making the connections to it. Again, assuming that you're pretty happy already with the alignment of the draft hood to the existing ductwork that you want to reuse, you can start with the water connections. The steps I recommend here are measuring and marking a place on the existing water line tubing where you think the end of the flexible connector will be, and then, using a reference from the connection manufacturer, identify how much of the existing pipe needs to be overlapped by the flexible connector. For SharkBite, there is a table for pipe insertion depth on the sharkbite.com website, or there's a deburr and gauge tool that you can buy that provides that depth. For the position of your cut will ideally account for the pipe insertion depth of the connector. However, the more slack you're planning to have in your flexible connector, the less exact you have to be with the cut. We talked about cutting the existing copper pipe already a little bit. Once you make the cut that you want to use for your flexible connector, it's important to deburr the pipe so that the burrs in the cut don't ruin the seal of the connection. There are several deburring tools you can buy. I used a combination tool that reams, cleans, and deburrs. Calling out the tools we've been referring to, I'll say that we've been using a tape measure, a marker, and a deburring tool in addition to the pipe cutter. I used a laptop to watch a video about how to use a SharkBite water heater connector just before I did the connecting task. I have a presentation document that I'll link to in the video description containing links to some of the videos that I found useful. The next step after the connections to the water lines have been made is to go back to that hot water faucet that you opened when draining the old tank and make sure that it's still open. If you're alone in the house and you know that you didn't close it since you started the project, maybe you can skip that step. At this point, it's time to turn the water on to the water heater and start filling the tank. While the tank is filling, I suggest working on the vent ductwork from the draft hood, followed by the gas connections. For vent ductwork, the standard seems to be 3 screws connecting the duct to the draft hood at an even spacing around the circumference. It seems that foil tape over the joints in the ductwork is a controversial idea that many inspectors don't like. The previous installer seems to have used foil tape, in my case, over all my ductwork joints in the past, so I followed suit. You might need tin snips, a power drill or screwdriver, and self-tapping screws to finish the venting job. After the ductwork is finished, the gas connection remains as the last major thing to do. For the gas connections, the PTFE tape or thread sealant should be used everywhere except for the connections at the flares of the flexible braided gas connector. We used both tape and pipe dope style sealant in different places, but if I had to do it over again, I would just use the PTFE tape. Using both wrenches consistently to stabilize the fittings as you tighten is important. During the reconnection work, the tank has been filling, and the signal of when the tank is full is when the water is flowing steadily out of the hot water faucet that you opened. The water will be cold, but that's okay. You haven't started the water heater yet. The faucet can be closed once the water has been flowing steadily, because the tank is full and there's no longer a need for an exchange of air for water within the tank and the water pipes. And when the tank is full and the gas is connected, it's time to test the gas connection for leaks. A soapy water solution and either a spray bottle or a brush can be the leak detection tool for checking the gas connections. I bought a bottle of leak detection solution from the home improvement store for the sake of convenience. Dishwashing detergent is popular as a soap for leak detection. I'd suggest finding a recipe for soap bubble play detergent on the web, if you decide to go that route. The task is just a matter of spraying or brushing the soap solution onto all of the connections that you've made and pressuring the gas lines by opening the gas valve. If bubbles grow or multiply, it's time to turn off the gas again and work again on the connection where the bubbles have formed. So the tools we add to the list are leak detection solution and perhaps a rag or two to dry off the connections and possibly the floor. Once the gas connections pass the leak test, the project is really in the final stretch. If the drain pipe for the temperature and pressure relief valve hasn't been reconnected, this is a good time to do that. And if your water heater needs electricity, it's time to run that cord and plug that in. Maybe earthquake straps still need to be installed. Your water heater's use and care manual has the instructions for how to get the pilot light lit and the burner going. I'm fairly sure that nearly all storage tank natural gas water heaters sold today are push button operated. In other words, they don't need a lighter or a match to get them going. Once you've started the water heater, I'd suggest continuing to monitor the situation for a little while. Maybe this is a good time to take the permanent marker and write the date of installation on the tank. In a little time, the water from the hot water faucet should start running warm. It's time to celebrate. Later on, you'll want to make sure to read and fill out the warranty information and submit any rebate you might be entitled to. So that's the process of replacing an atmospherically vented natural gas water heater as I know it. In the description of this video is a link to get you a copy of the slide presentation I made. It might help as it has links to brief videos to use on the day you actually physically turn the valves and wrenches. Now that we've talked our way through the water heater replacement project, you might be wondering how long to expect the actual installation work to take. In my experience, it was 6 hours from hooking up the hose to the drain valve to feeling warm water flowing out of the tap. For the purchasing and research and the collection of the tools and materials, I would be a little embarrassed perhaps to share how long it took. I was very proud, however, that at least we didn't have to head back to the home improvement store on the date of installation. My hope is that with notes like the ones in this video, your purchasing and preparation time could be 4 hours or less. In my water heater replacement project, I didn't confront the need for several items that may be a concern for you, such as the potential need for a thermal expansion tank, earthquake straps, or the low NOx requirements. And I didn't learn much about other vent types besides atmospheric. So this video is limited in those aspects. I'll put some links to those topics into the slide presentation that is available via a link in the description for this video. Kindly like and subscribe to this channel if you might like to see more videos from me related to natural gas water heater replacement. I'm thinking of breaking this long video up into smaller pieces for convenience. I'm also thinking of highlighting other things I've learned about plumbing and water heaters. Thank you for watching.